In this video, we are going to look at a sampling without replacement example. This is a more realistic type of sampling where you select 4 different fuses, or let's say you would select a fuse. Once you tested whether it was good or not, you kept it out of the box. So sampling without replacement is how most sampling is done. You pick different fuses. You could grab them all at once, or you pick one, look at it, set it aside, pick another one, look at it, set it aside. No replacement. So sampling without replacement. Now when you sample without replacement, you will end up with dependent events, because what you select the second time depends on what you selected the first time, and because the number of items in the box are changing, we have conditional probabilities. So whenever you're sampling without replacement, you end up with dependent events and conditional probabilities, because based on what you've selected prior affects the consequent probabilities. So we'll look at the same kinds of questions before the sampling without replacement exercise. We're going to have 40 fuses like we did with the with replacement exercise. Same defective rate of 15%. We still choose 4, but this time they're all different, which means we're sampling without replacement. So what's the probability when sampling with replacement? None of the fuses are defective, or in other words, they're all good. So the probability of good, 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 good. So in order to do this, though, the 15% rate is going to change. So what we really need to know is how many of these fuses are defective and how many of these fuses are good. So we have 15% defective, so that means 15% of the 40 fuses are defective. That gives us 36 defective fuses. That means the remaining 34 must be good. So if we want the probability that all of them are good, the first thing we know is the probability the first one is good, and there are 34 good fuses out of 40, so the probability the first one is good is 34 out of 40. Now we need to multiply that by the probability that the second fuse is good, given the first selected fuse was good. We took one good fuse out of the box, so there are only 39 good fuses, and 33 of those are good, so there are 33 out of 39 good fuses in the box. And now we want to select a third fuse, and we have 2 good fuses have been removed from the box, so that leaves 32 out of 38 good fuses, and then when that is removed, there are only 31 out of 37 good fuses left. So we end up with 34 out of 40 times 33 out of 39 times 32 out of 38 times 31 out of 37 to give us 0.50745. In this next example, we want the probability that they're all defective. So the probability of defective, 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 defective without replacement. So the probability that the first fuse, the probability that the first fuse is defective. Well, there are 6 defective fuses out of 40, so 6 out of 40. Now we leave that fuse out of the box, so there are only 5 out of 39 defective fuses left. We leave that fuse out of the box, so there are only 4 out of 38 defective fuses left. And finally, we leave that one out of the box, so when we select our 4th fuse, there are only 3 out of 37 defective fuses left. So that gives us a probability of defective, defective, defective as 0.00016. How about the probability the first 2 are good and the last 2 are defective? So that's the probability of good, good, and defective, defective. So the probability the first one is good, remember 34 out of 40 good fuses, and the second one is good, 33 out of 39 good fuses, And the next one is defective. We still have 6 defective fuses, but there are only 38 fuses left. We leave that defective one out, and there are 5 out of 37 defective fuses left to give us 34 out of 40 times 33 out of 39 for the good, and then times 6 out of 38 times 5 out of 37 for the defectives to get 0.01535. Now, how about the probability the first 2 are defective and the last 2 are good? So the probability of defective, defective, and good without replacement. Will this be the same as the first 2 good and the last 2 defective? Well, the probability the first one is defective is 6 out of 40, and we leave that fuse out of the box, so there are 5 out of 39 defective fuses left. Now we leave those 2 defective fuses out. We want the probability of a good fuse. There are 34 out of 38 remaining fuses that are good. And finally, the last fuse good. There are 33 good out of 37 total fuses remaining. Notice the denominators are still 40, 39, 38, 37. The numerator still has a 6, a 5, a 34, and a 33 being multiplied together, but it's just in a different order, so we get the same probability. And now, what we want to do is say, okay, instead of order mattering, what's the probability exactly 2 are defective? And just like before, we want to know how many ways to choose 2 defectives from 4, right? Because how many of those 4 fuses are actually defective? And we saw last time that that's a combin. So formulas, math and trig, combin 4, choose 2, and remember that was 6. But now there are 6 ways to get exactly 2 defectives. Each of the 2 defectives has the exact same probabilities, so we can just go equals this 6 times either of these probabilities, because they're exactly the same, to get 0.09208 for exactly 2 defectives.